So as you can see, factoring is not terribly difficult as long as you approach with a plan. So the plan is, what do you do when you have 2 terms versus 3 terms versus 4 terms? And each one of those have an answer that we already answered in this section. So at this point, let's continue example number 6, and we have negative 15x squared minus 3x cubed minus 18x next. First of all, this is not written in the correct order. We typically in math like to have what's called the standard form, which means the highest power goes first. In this case, the negative 3x cubed has the highest power, so that should be first. Then the negative 15x squared, and then finally the 18x. This is what we call the standard form because the order goes from 3 on the power to 2 to 1. And as you can see, I have 3 terms. But before I get into the x method, which by the way does not work in this case because the power is 3, not 2, the x method does not work. What I have to do first is look at the GCF. Is there a common factor repeating in this term, the second term, and the third term? The answer is yes. All 3 of them have a minus. All 3 of them have a 3 because 3 is 3 times 1, 15 is 3 times 5, and 3 times 6 gives me the 18. And also, there's an x that repeats inside all of the terms. So we're going to take out the factor negative 3x, which is what we call the GCF. And at this point, we're going to ask what's left inside each of the terms. So to figure out what goes inside the parentheses, it's very straightforward. Take the old numbers and divide it by negative 3x, and you get x squared. Take the old number negative 15x squared, divide it by 3x, and you get positive 5x. Then finally, if you did the same thing with the negative 18x divided by negative 3x, your solution will be positive 6. That's what goes inside the parentheses. If you don't believe me, go ahead and multiply it out in your mentally. You know, it's like multiply the 3x with the x squared, you get back the first term. Multiply the 3x with the 5x, you get back the second term. And again, 3x times the 6, you get back the third term. We're obviously not going to do that because we're factoring, but that's how you would check it. So at this point, we have to check that the trinomial x squared plus 5x plus 6 factors or doesn't factor. And what we're going to do is use the little x diagram method. This is the simple version because of the 1 in front of the x squared. So we're going to put 6 on top, 5 on the bottom because of the 6 that was at the end and because of the 5 that's in the middle. So are there 2 numbers that multiply to 6, but when you add them, you get 5? The answer is yes, 2 and 3. So write the negative 3x first, then put 2 parentheses, and we can use the shortcut in this case. Because there's a 1 in front of the x squared, we can write down x plus 2, and finally x plus 3. And that's literally the end of the problem. So again, it sounds complicated at the very start, but if you organize your work, it should be very straightforward. Let's look at this next one with the 2x cubed y plus 4x squared y squared minus 6x y cubed. If you're wondering how to organize this, typically speaking with these problems, we pick one letter and we organize it with respect to that letter. So if you look at the letter x, for example, I have the x cubed first, x squared next, and then x afterwards. So it's already organized in terms of the x. And that's enough to keep it like this, to put it in standard form. So next, look at the GCF method. Is there a common factor in all of my 3 terms? The answer is yes. There's a 2 in all of them because 2 times 1 is 2, 2 times 2 is 4, 2 times 3 is 6. There's an x that repeats because of the x cubed slash x squared slash x. And also, there's a y that repeats because of the y, y squared, and y cubed. Okay, so if we take away the 2xy from the first term, their leftovers are going to be just x squared. The middle term leftovers will be 2x and y. And finally, the third term will give me negative 3y squared. And again, this is a trinomial, and it has a 1 in front of the x squared. So let's try to do this little diagram. Negative 3 goes on top, and the 2 goes on the bottom. Are there 2 numbers that multiply to negative 3? But when you add them, you get 2. Let's give it a shot. If I try negative 1 and positive 3, that should get the job done. So again, where did I get negative 3 from? It's the last term that goes on top. What about the 2? It's from the middle term. And shortcut is okay because I have a 1 in this case. So what I'm going to do is write down 2xy, and then the letters of the problem, x and y, x and y. One time put a -1, one time put a +3. So how come I put the x and the y like I did? I put them like that because x times x will give me back the x squared, and then the y times the y will give me back the y squared that I needed. So that's the reason for the work that I did. Okay, so the final one is 10x squared plus 26x minus 12x squared. So we have 10y squared plus 26xy minus 12x squared. And again, it doesn't have to be written in alphabetical order with the x first. As a matter of fact, if you put the x first in this case, you'll end up making the problem a little bit more difficult than it really is. However, I have 10, 26, and 12, which are all factors of 2, or let's say multiples of 2. So I'm going to take out the 2. That leaves me with 5y squared and 13xy, which is positive. And then finally, the negative 6x squared. Okay, so this is by looking at the 3 terms in the beginning and looking for the GCF, which is the 2. So now that I've done that, I have a problem inside the parentheses with 3 terms. So let's see if I can try to factor this. So again, 5 times -6 will be at the end -30. And in the middle, I have 13. So I'm going to write that in the bottom of my diagram. So again, multiply the first one with the last one to get the number that goes on top, and just copy the middle term to the bottom of the diagram. So at this point, we're looking for any 2 numbers that multiply to -30, but when you add them, you get 13. And again, there is a pair that works. 2 and 15 works as long as you make the 2 negative and the 15 positive. And unfortunately, this one is the no shortcut problem. So what does that mean? That means I have to go and write down the 2, then write down the 5y squared, copy the 2 numbers that I got, which are -2 and then xy, and then the 15xy again, then finally -6x squared. Now, I put the -2 first and the 15 after because I like the pattern plus minus plus minus, but some folks will go and write down 5y squared plus 15xy minus 2xy minus 6x squared, and that will also work just fine. It's up to you really, it's your preference. There's nothing sacred about this order that I chose. But what I do next is factor. So what does the first pair have in common, and what does the second pair have in common? So the first pair, just a y. That leaves me with 5y, -2x. The second pair, there's 15 and 6. The common factor there is 3. There's x and x squared, so we can factor the x out. That leaves us with 5y, and then again, -2x. And as you can see, the 5y minus 2x inside the parentheses is repeating inside the first parentheses and inside the second parentheses. So at this point, what we do is grab it and write it first. 5y minus 2x, and then write down the leftovers, y plus 3x inside a second parentheses. And the brackets could be there, but also they don't have to be there. You can remove them, it's up to you. This is it. That is the final answer.